Okay, YouTubers, working on getting an update here for the SDR. We got the controller mounted today for the loop antenna, and then we mounted the SDR in a box so that it wouldn't rattle around. This thing was really loose, the USB, and it kept coming loose on me. And it disconnected a couple times, so I got sick of that and put a fan in it to keep it cool because it was getting hot and now it's not. And of course we wired in the LNA, put some LEDs in it. I'll show you the back. Just got a wire sticking out there for the USB and the antenna wire, and that's it on that one. And then of course I got the mag loop controller. I finished the loop antenna. It's around here. We reinforced it. I put a longer pipe here all the way through. Got the motor mounted. This is a 1 in 5 speed motor. I got it off eBay or Amazon, and it came, I got the bracket and this with it, the mounting thing, clamps. I went ahead and put a shaft into this and put it I didn't have anything to put through it, so I just stuck a drill bit in it and then broke it off so that it would work as a shaft to hold the shaft in, and it works great now. I will give you a tip. The wire that you use coming down off of here, leave it as short as you can, and get you some shielded wire. I didn't use shielded wire, and man, it put a lot of noise into the antenna even when it wasn't on. For some reason the antenna was coupling to it, I think, so I had to get shielded wire. This is 22 gauge shielded wire. They use it for alarm systems, and it works great. There's no noise in it now whatsoever. The only noise I get, because this is a brush motor, you get little spikes of noise when you're rotating it. But the only other option is a stepper motor, and if you go with a stepper motor, you're talking a lot of money because you're going to have to buy a controller and some kind of power regulator thing, and you have to program the damn thing with an Arduino, and it was going to be a headache. So I opted for the worm shaft. This is a worm shaft motor. It mounts sideways instead of up and down, because I bought, this is the 1 in 5, but it's not the lowest torque. I went up a step in the torque because this massive capacitor here. But I did get it to work. You can see how I got it all mounted there. PVC pipe. This is 1.5 inches here, reduced down with the reducer to 1.25 inches. This is 1.25 inch pipe right here and here, and then this is 1.5 inches, and then use the reducer so you double your strength up where your poles go in, where your PVC goes in. But yeah, that's pretty much the antenna. I'll step back so you can see it. It's pretty much the same as it was. Works really good. I'll show you some. This is the connections. I modified the connections a little bit, and I moved this one from down here to where it was, where they had the original, and I put it up here. It didn't matter a bit, so I got a shorter length here now, and it took a lot of noise out of it. I also run it outside. I can't show you that, it's dark, but it's run outside to a junction box, a run-through box that I've got to ground. So it is now grounded, and that dropped my noise floor 10 dB by grounding it, running it through a ground. But you can see the loop, and I flattened this here, right here, a little bit, okay, so that it couples better up here, and I flattened this a little bit here too, and that helped it couple. But other than that, that's pretty much it. Stuck it in a flower pot. I'm eventually going to weatherproof this and put it in a weatherproof box along with the motor. I wanted to get it all working first before I went any further, make sure everything was okay. But I'll step you over to the controller now. This is the controller. I put a switch in it for shut it on and off. This is a laptop, or actually it's a Cisco router power supply. I cut the cord on it and made it real short and connected the 5 volts to the fan and the LEDs. And then I took the 12 volt from that power supply and run it to the controller. That's a forward reverse stepless controller. Got it on Amazon. Comes with a little forward and reverse switch here, and then a tuner knob to crank up the voltage to however speed you want it. I find mine works real good at about 12, so I leave it at about 12. But that was the fan. I put that in there because they said they were running hot, but I've stuck my hand in there a few times and it's not very warm at all, so it must be working. But I put the laptop, or excuse me, the router, old router, same thing as a laptop power supply in there, and it is noisy. It's a switching transformer, but it's shielded. The only problem I had was the wire coming from the motor out. I'll show you the back. Here's the back. This is an electric plug for the power supply that's in there, and this is the 12 volt that goes out to the motor on the loop right there. And I put them in. I had an old set of course you might recognize that Sony speaker case there. I just ripped the speakers out and created a case here, and of course that's the SDR. Like I said, I had to put a fan in it. This is the fan out of the Cisco router. But yeah, the SDR was running hot, and so I had to fix that, change that, keep it cool. Plus it doesn't move now, it's real solid in there. I used a piece of PVC pipe to stand it off so I could glue just the edges to it of each one. And then of course I glued the antenna part to the top there, and I run that 5 volts coming from this here. I drilled a hole in it, and you can see it back there. I pulled the 5 volts from the USB out of there to run the fan and the lights, the LEDs. And then that's the controller. You can see the connections inside there for the motor and the 12 volt. And this is a switching power supply right here, and you have to short 2 wires to get it to turn on. Whenever I voltage tested it, I could only get 17 volts out of 1 wire, so I took that wire and I grounded it, and it turned the switching power supply on, and I was able to get the 5 and the 12 volt out of it. So that's just a hint for you. You can voltage test the wires, and if you've only got like 17 volts and it says it's doing 12, then that's usually your switch wire. So I did not you know, record any of that. So, but the fan is a 12 volt fan out of a computer, and I'm running it at 5 volts. So, and it runs fine. This one over here is a 5-volt fan, so but it runs a little slow, but you can feel the air coming out of the top of it, so it keeps it really cool. But I was playing around on 40 up here tonight, and the signals were just booming. So yeah, there's a lot of action tonight on 40. I was playing around tuning the loop, and I've got it working really good now. That's covering everything in 40 meter right there, and you can see the peak of the loop antenna right there, and it covers clean over receive wise. It's got a wide band, and I figured out why it has such a wide band. I used the small wire on here, 6-gauge wire, grounding wire, but what I did by doubling it here, I brought it down and connected it here. It thinks it's a 1.5 inches, almost 1 3/4 wide. It thinks it is because I connected it down here, but up here, that's what gives you your wider bandwidth. Instead of using a full round copper pipe that's heavy, and you can do it this way, if you go too far on your spacing, you'll lose it. You have to get it. These are cut, I think, at 1.5 inches right here, and so there's a little bit on each side there, so it may be less than 1.5 inches, but the antenna thinks it's 1.5 inches diameter pipe. That's why I'm getting such a wide band, a wide area of receive with it. It's absolutely huge. I'll move it for you so you can see. Let's go backwards. There it goes. So now we moved it over here. It was here, but this switch right here is a contact switch. It's not a momentary, so if you push it down, you gotta push it back over. So I'm gonna try to get a momentary switch for this, so we can go left and right. Let's turn it back the other way. Now we're way over there. Sorry about the camera. Turn it back. There we go. And now we brought it back here. You can see what happens. It just dies. It loses everything until that edge comes in. It literally is like a cone of receive with it. It's awesome. But yeah, 40 meters is blowing up tonight. I've been listening in and fine-tuning the SDR there. I finally got it all working and hooked up, and now the magnetic loop has its own controller, and like I said, I run the coax out the window there, and I run it out to a junction box. You can see it on my first video. It just passed through that I attached ground to, so I can get a ground to it, and it took all the noise away. It took a lot of noise. What you're seeing here is pure dB. Anything you put into that peak will become red automatically. You can see them. Whatever you put in that peak, it could be a little squeaker signal way over here. You move that peak over to there, and it will turn it red. It will pull. It is an amazing what you get out of this as far as receive. I was shocked. But I'm gonna add one more thing. I'm having trouble on 20 meters, and I figured out what it is. This capacitor, I think it's on the bottom. Let me check. Yeah, it's written there. You can see is a 64 910. The 910 number gets me down to 160 into medium medium wave, but that 64 number doesn't get me high enough into 20. I noticed I'm losing my peak on 20 and above, so what I'm gonna have to do is buy a lowest number I can, 1 to 100 or so, and I'm gonna mount it off this side here with another stepper motor, and then I can fine tune with that other capacitor that I'm going to mount here, and then this will be my big capacitor for running the running through the, and then I should be able to get down to 20 meters by adding a lower number capacitor onto that. And I'm going to run dual capacitors and probably run them parallel, so I'll run them one to each one and then back to the antenna. I'll try series or parallel and see which one works better. I believe parallel is going to work better if I get that. But this is a transmitting capacitor, and it's a good one. It's a Hammerland Schmidt or something like that. Really good capacitor. But yeah, I thought about splitting it here and using the two, but they're actually made into one. I tried it and it still was connected, so that didn't work. But you can see the slot I cut in the PVC pipe to mount it flat on a plastic. I mounted it first on a piece of plastic and then PVC. The reason why I used silicone here, rubber, is because you're not going to get your alignment perfect right here. The best thing to do is get this mounted and then let this motor dangle off of it and be natural in its natural spot, and then try to maneuver your thickness out to that motor and try to keep it from being shifted either way. It was difficult. I figured out all I had to do was just put one little piece of cut PVC pipe in there as a shim, and it held it nice and tight. It's solid as hell. So that's the update on the mag loop, the update on the SDR, and like I said, whenever I get the other capacitor in, I'm gonna mount it on this side, but I'll have to take the whole thing apart to get this out. It's the main shaft, so I can replace this with a one of these, one of those. So that's going to take quite a while. I'll have to unsolder all these ends of the wire and pull them apart. But once I get it mounted and get that other one off this side, I'll have two motors. And what I figured I'd do is run another controller inside here on this box, maybe on this side, off the same power supply, and then have two controllers. I've got this one. This is another speed controller you can get from eBay or Amazon. But it has just a on and off switch. That's it, on, off, and of course your speed control. But I noticed this one was really touchy. It's only got 1K variable, 100K I think it was. This one here has a better one. This one here has an on and off switch for the voltage, which was nicer. So I went with this one, and it was forward and reverse. Had a switch for forward and reverse. So you can go with this one though. I used it for a while in this box, but I needed the reverse. I knew I needed the reverse, so I went ahead and used it until I was able to get the other one. But this one here did work. It was just a speed controller, that was all. But you had to time it. When that thing was moving across the band, you had to hit this button just right to get it to stop where you wanted it, or else it would go further and then you couldn't back up. So that's why I went with the the reverse one. It was a lot better. It just works a little better. But I like this bigger screen versus this smaller number one. This thing is little, it's dinky. But yeah, my motor seems to like 12 real good. But it's really touchy. That little variable is really touchy. But that's it. You can see inside it's wire mess, but it works. This switch right here and that variable came with that controller and this. So it all came together in one package. So all I had to do was put the power supply in and the LEDs and the fan, and then the switch for the on and off. And that's like I said, I used this one. It does work. You can use it. It's about the same price though as this one. So, but I ordered this one to start with and thought it would work, but I found out I needed reverse. So, but yeah, that's it. And then of course I've been testing with the LNA and getting the antenna 2 meter up for the Azu there. Got it up and running. But yeah, it looks like 40 meters is really kicking tonight. So I wanted to make a new video to update y'all on what I've done here. And I was able to get my antenna up. I'll try to include a picture. See if I can edit that in. I'm gonna try with my hand at editing. So, well, anyway, I hope y'all enjoy. It does a hell of a job. I'm really pleased with it. And just remember the shortcut. If you want, you can make a loop without having to go with that big thick round pipe. You can trick it by, you can even add another one over here and make it think it's really huge, and that'll expand. But as you can see, the way I mounted it too, if you could come up with a design for up here to maybe come off with 3 or 4 that are just closer together, 1.5 inches here, you'd probably get it to work just fine. But I went with 2 because it needed the wider bandwidth. So, but it works great. And like I said, the stepper motor is awesome. Stepper motor works great. So, other than that, well, I hope y'all enjoy, and I'll try to make another video here whenever I get the other capacitor on the loop, and we'll see if we can't do some tuning with 2 capacitors. I'll make it a dual capacitor one, and we'll see if we can't get it working. Alright, well, you guys take care, and 73.